66 million years ago, the Earth was alive with giants. Herds of hadrosaurs thundered across floodplains, titanosaurs towered like moving hills, and apex predators like abelisaurids prowled in the shadows. Forests stretched endlessly, insects buzzed in humid air, and the age of the dinosaurs seemed unshakable, eternal. But above this world, far beyond the clouds, in the darkness of space, death was already on its way. We all know the story. A mountain-sized asteroid called Chicxulub struck near what is now Mexico's Yucatan Peninsula. In a single instant, firestorms ignited, the atmosphere burned, and nearly 3/4 of Earth's species vanished forever. It is remembered as the event that ended the reign of the dinosaurs. But what if the story isn't so simple? What if Chicxulub wasn't alone? In 2022, scientists studying the seafloor off the coast of West Africa discovered something astonishing. A massive crater hidden nearly 3,000 feet beneath the Atlantic Ocean. They named it the Nadir Crater. It measured almost 6 miles wide, smaller than Chicxulub's 120-mile scar, but still vast enough to swallow cities whole. And most chilling of all, it was dated to the exact same time as the Chicxulub impact, 66 million years ago. Could it be that Earth wasn't struck once, but twice? Imagine for a moment that you're standing on an ancient Cretaceous shoreline. The air is warm, heavy, with the smell of salt and vegetation. Giant reptiles glide through coastal waters, while herds of dinosaurs move inland across lush plains. The horizon looks peaceful, but above, a new star has appeared. At first faint, then brighter, then blinding. That star is the Nadir asteroid, a half-kilometer-wide rock hurtling toward Earth at more than 70,000 kilometers per hour. 11 times faster than the deadliest weapon humanity has ever built, and billions of times heavier. The dinosaurs never stood a chance. As it entered the atmosphere, the asteroid grew brighter than 20 suns, casting shadows in every direction. For a few terrible moments, it was daytime at midnight. Birds panicked, reptiles stirred, and then, with unimaginable force, the asteroid slammed into the ocean. The sea exploded. A fireball larger than Central Park erupted, vaporizing water, rock, and everything within miles. A shockwave raced outward, flattening forests and hurling creatures like toys. The blast was equivalent to 5,000 megatons of TNT, more explosive power than all the nuclear weapons on Earth today combined. And then came the water. The impact displaced billions of tons of seawater, raising a wall 3 times taller than the Eiffel Tower. That tsunami swept outward in all directions, scouring coastlines of Africa, slamming against the Americas, drowning everything in its path. For the dinosaurs that survived the first moments, the burning air, the searing light, the hurricane-force winds, the wave was inescapable. The Earth itself shook. The seafloor cracked, triggering a magnitude 7 earthquake. Massive deposits of carbon and sulfur were blasted skyward, seeding the atmosphere with poisons. And though the Nadir asteroid was smaller than Chicxulub, its landing point made it deceptively dangerous. Striking an area rich in volatile minerals, it unleashed clouds that could have altered climate for years. Was this the opening act to the extinction? A smaller, savage blow that weakened ecosystems before the final Chicxulub strike arrived? Or did both impacts happen almost simultaneously, delivering a 1-2 punch so devastating that even Earth's most resilient creatures could not adapt. Scientists are still searching for answers, but one thing is certain: the dinosaurs' world was far more fragile than it seemed. And as we piece together their final days, the possibility of a second asteroid makes their extinction not just tragic, but terrifying. Because if it happened then, what would it mean if it happened again today? For millions of years, the Atlantic Ocean kept its secrets. Beneath its rolling swells, the seabed bore scars of ancient forces, mountain chains, trenches, and buried volcanic ridges. To the casual eye, it was nothing more than a map of shifting geology. But in 2022, something strange caught the attention of a team of geologists reviewing seismic data collected from the ocean floor. They weren't looking for an asteroid crater. They were studying the structures of Earth's crust, how tectonic plates shifted, how sediments settled. But hidden within the layers of rock, they saw something unusual: a perfectly round depression, almost 6 miles across, buried nearly 900 meters beneath the surface of the Atlantic. This structure was later named the Nadir Crater, after the nearby Nadir Seamount. At first, it looked too neat, too circular to be natural. And geologists have a saying: on Earth, perfect circles are suspicious. Most geological processes, volcanoes, earthquakes, erosion, leave messy, jagged scars. But an impact leaves behind something unmistakable: symmetry, shocked minerals, a rim blasted outward like a frozen splash. As researchers examined the data more closely, the pieces fell into place. The Nadir structure bore all the hallmarks of a colossal impact crater: its shape, its depth, its fractured edges. But what made the discovery astonishing wasn't just its size, it was the age. Tests on surrounding rock layers suggested the crater was around 66 million years old, the very same time period as the Chicxulub impact. This was no coincidence. For decades, the Chicxulub asteroid had been considered the sole culprit behind the dinosaurs' extinction. A single bullet fired from the cosmos, ending 160 million years of evolutionary dominance. But the Nadir crater raised an unsettling possibility: that there had been more than one bullet. The scientific community was cautious. Extraordinary claims demand extraordinary evidence. Was Nadir truly an impact crater, or could it have been something else? An underwater volcano, a collapsed seafloor structure. In 2023, further studies confirmed the worst. The Nadir site showed unmistakable signs of a high-energy collision. Shocked quartz, deformed layers of rock, and the geometry of the crater all pointed to an asteroid strike. Now the question wasn't if it was an impact. The question was when. Did Nadir strike the Earth on the exact same day as Chicxulub? Was it part of a swarm of asteroids, fragments of a larger parent body that shattered on its way toward Earth? Or did it arrive days, months, even years earlier, softening ecosystems, destabilizing food chains, leaving dinosaurs vulnerable for when the final blow came? Imagine 2 massive asteroids entering Earth's atmosphere within hours of each other, one targeting the Gulf of Mexico, the other crashing into the Atlantic. The planet would have shaken violently. The skies would have burned twice. The oceans would have risen in tsunamis from 2 directions. Even for Earth, such a double strike would be extraordinary. Impacts of Nadir's size occur only once every 50,000 to 100,000 years. The odds of 2 happening within the same geological instant seem almost impossible. And yet, the evidence points to exactly that. The discovery of the Nadir crater sent ripples through the scientific world. Suddenly, the extinction of the dinosaurs looked less like a single unlucky event and more like a cosmic ambush. And the more scientists studied Nadir, the more terrifying the picture became. This wasn't a small asteroid. It was half a kilometer wide, traveling at 70,000 kilometers an hour. It carried more destructive energy than every nuclear warhead on Earth combined. And unlike Chicxulub, which struck near land, Nadir plunged into deep ocean, adding the destructive force of mega tsunamis and underwater shockwaves to the devastation. If Chicxulub was the gunshot that killed the dinosaurs, Nadir may have been the knife twist. And yet, the mystery remains. Was it the first strike, the second, or merely a coincidental arrival during Earth's darkest hour? The crater sits silent now, hidden beneath the Atlantic waves. But in its silence lies a story of violence, a story written in stone, waiting for us to uncover it. Because understanding Nadir isn't just about rewriting the past. It's about recognizing that Earth's greatest threats don't always come from within. Sometimes they come from the stars. To understand what the dinosaurs faced, we need to step back and imagine what happens the moment an asteroid meets Earth. At first glance, space seems empty. But asteroids, ancient fragments of rock and metal, left over from the birth of the solar system, drift silently across it. Most pass harmlessly by. Some are captured by Jupiter's gravity and slingshotted away. But every once in a while, the Earth is in the wrong place at the wrong time. And when that happens, the results are apocalyptic. The Nadir asteroid was small by cosmic standards, only about 500 meters across, less than half a mile wide. But size isn't everything. It was traveling at nearly 72,000 kilometers per hour, more than 20 kilometers every second. At that speed, even a relatively modest asteroid carries energy beyond comprehension. When an object like this strikes, it releases energy equivalent to thousands of nuclear bombs. In Nadir's case, about 5,000 megatons of TNT. For comparison, the bomb dropped on Hiroshima released only 0.015 megatons. The numbers are staggering. But let's leave the numbers aside for a moment. Let's picture it. First, as the asteroid slams into Earth's atmosphere, friction ignites it. A blinding streak of light tears across the sky, brighter than 20 suns. Shadows vanish. The air trembles. Animals panic. In those last few seconds, the asteroid is no longer silent. It screams, a deafening roar, as it compresses air in front of it. Then comes the strike. In less than a second, all that kinetic energy is transferred to the ocean. The sea doesn't yield gently. It explodes. A fireball the size of a city forms instantly, vaporizing millions of tons of water. Steam rises in towering columns. The surrounding atmosphere ignites, superheating the air and burning any creature caught within sight of the blast. The impact carves a crater nearly 6 miles wide. Seafloor rock shatters and fractures. Pressure waves shoot through the ocean like bullets, stunning or killing marine life far from the site. Then the water rushes back in. Billions of tons collapse into the crater, displacing everything outward in a monstrous surge. The tsunami that follows towers higher than skyscrapers. Near the impact site, it might have reached 1,500 feet tall, 3 times the Eiffel Tower. Entire coastlines vanish beneath it. Forests are stripped bare. Anything alive on shore is dragged screaming into the sea. But the devastation doesn't stop there. The energy released by the impact sends shockwaves through the crust itself. The ground lurches. Earthquakes ripple outward, powerful enough to topple forests and reshape river systems. In some places, the seafloor tears open, releasing trapped gases and reshaping underwater landscapes. Above, the atmosphere is poisoned. The impact struck a region rich in carbon and sulfur deposits. When these elements were vaporized, they were lofted high into the sky, mixing into the air currents. Carbon and sulfur aerosols linger for months, even years, blocking sunlight, cooling the planet, and acidifying rainfall. To a dinosaur, these changes were invisible at first. But slowly, plants withered, insects declined, herbivores starved, and when the plant-eaters fell, so too did the predators who hunted them. The nadir asteroid alone may not have ended the dinosaurs, but it would have been enough to shake their world, to weaken ecosystems, to push populations toward the edge. Now imagine this happening not once, but twice. Chicxulub, larger and deadlier, was the killing blow. But if nadir struck shortly before, or even at the same time, then the age of dinosaurs ended not with a single catastrophe, but with a double apocalypse. And the terrifying part? Impacts of this size are rare, but not unique. Statistically, another nadir-sized asteroid will strike Earth again. Maybe not in our lifetimes. Maybe not for tens of thousands of years. But someday, somewhere, the sky will fall again. For the dinosaurs, there was no escape, no warning, no defense. Their final moments were written in the violence of physics itself. And as we uncover their story, we're forced to ask, if Earth was struck today, would humanity fare any better? The late Cretaceous was a world of abundance. Dense forests sprawled across warm continents. Rivers wound through valleys rich with life. Giant titanosaurs grazed in herds, stripping trees bare. Hadrosaurs splashed through floodplains, while predators like abelisaurids stalked the edges of herds, waiting for a misstep. It was a thriving planet, a paradise of scale and diversity. And for millions of years, dinosaurs ruled it with unchallenged dominance. But paradise ended in fire. When the nadir asteroid slammed into the Atlantic, the first creatures to witness it were those along Africa's western coasts. Picture a group of titanosaurs moving along a shoreline, their enormous bodies casting shadows across the sand. Suddenly, the horizon blazes with unnatural light, so bright it outshines the sun. The sea glows. The air itself grows hotter with every heartbeat. In moments, their skin burns. Some collapse instantly, scorched by radiation and heat. Others bolt inland, but it doesn't matter. The shockwave follows, a hurricane of superheated air blasting outward at hundreds of miles per hour. Forests snap like matchsticks. Dinosaurs are thrown to the ground, crushed beneath falling trees. And then the ocean rises. The tsunami surges inland, swallowing everything. Creatures who survived fire are drowned by the flood. Nests are washed away. Whole populations vanish beneath waves taller than any mountain they had ever seen. The lucky, or perhaps the unlucky, survivors retreat inland, bewildered and terrified. For a time, life limps on, but the skies are no longer the same. The nadir impact injects massive clouds of sulfur and carbon into the atmosphere. Days grow darker. Rain becomes acidic. Plants begin to wither. For herbivores, this is a death sentence. As the forests thin and food disappears, massive herds break apart. Hungry, desperate, they wander into barren landscapes. Titanosaurs, once unshakable giants, grow weak. Young hadrosaurs starve before they can reach adulthood. And predators, who rely on the weak and the sick, suddenly face starvation themselves. But the true nightmare has not yet arrived. Thousands of kilometers away, across the sea, Chicxulub is coming. And when it strikes, it will not just scorch and flood, it will smother the planet itself. For the dinosaurs, there was no way to know that two disasters had aligned in the same age. But to imagine their last days is to imagine a world unraveling piece by piece. In Africa, once rich wetlands dry into wastelands as climate falters. Rivers turn murky, poisoned by ash and acid rain. In South America, herds scatter in confusion, their migration paths broken by failing ecosystems. In North America, predators like T-Rex may have feasted briefly on weakened prey, but even their reign was short-lived. The world grows colder. Ash and dust blot out the sun, plunging regions into twilight. Temperatures drop. Photosynthesis halts. Insects die off. Flowers, grasses, and trees falter. The chain reaction continues upward. Herbivores collapse. Carnivores follow. Imagine a hadrosaur standing in a clearing. Its ribs are visible, its muscles wasted. It calls out, but no herd answers. The forest around it is silent. No buzzing insects, no rustle of prey. Only the distant crash of waves and the hiss of falling ash. This is how extinction feels, not just in fire and violence, but in silence. And still, some dinosaurs endured for weeks, months, maybe even years after the Chicxulub strike. But survival was not the same as living. Each day grew harsher, each season shorter. Eggs failed to hatch. Juveniles failed to grow. Populations dwindled until the last survivors vanished into the shadows of history. When it was over, the world was emptied of its giants. No more titanosaurs to shake the earth with their steps. No more hadrosaurs to echo across the plains. No more predators to stalk them in the forests. The age of dinosaurs ended not in a single moment, but in waves of death, fire, flood, famine, and frost. And if the nadir asteroid was indeed part of that story, then the extinction was not only brutal, but mercilessly compounded. For 160 million years, dinosaurs thrived. And in less than a human lifetime, their kingdom crumbled into ash. For decades, the story of the dinosaurs' extinction seemed straightforward. One asteroid, one moment, one cataclysm. The Chicxulub impact in Mexico was the villain, the smoking gun that ended an age. But science is rarely that simple. And in 2022, a discovery forced paleontologists to reopen the case. Beneath the Atlantic Ocean, off the coast of Guinea, researchers found something strange. A massive circular structure buried beneath the seafloor. It was 9 kilometers wide, carved deep into the crust, and its very shape whispered of violence. Seismic scans confirmed what many suspected. This was no ordinary geological formation. It was a crater, an impact scar. And when scientists dated the rocks, the result was startling. The crater was roughly 66 million years old, the same age as Chicxulub. For the first time, the possibility emerged that the dinosaurs did not face one cosmic assassin, but two. The mystery of timing. The heart of the debate is timing. Was Nadir created on the very same day as Chicxulub? Or did it strike a few years, or even decades, earlier? If both asteroids arrived together, perhaps fragments of a larger parent body that shattered in space, then the extinction was likely faster and more violent than we ever imagined. One asteroid on its own was enough to plunge the world into darkness. Two could have amplified every deadly effect: fires, floods, acid rain, and famine, turning survival from unlikely to impossible. But if Nadir struck earlier, even by a few decades, its role changes. Instead of doubling the blow, it may have acted as a grim prelude, softening the world for Chicxulub's final strike. Imagine ecosystems already fragile, food chains already wobbling. When the bigger asteroid arrived, there was nothing left to resist. Either way, the dinosaurs' fate was sealed. But the difference matters. For science, it changes how we understand extinction, not as a single apocalyptic day, but perhaps as a cascade of disasters. The case for two asteroids. There are clues that suggest Nadir and Chicxulub were siblings in destruction. Similar age. Both craters date to the very end of the Cretaceous, within the margin of error for the same event. Size and impact. Though smaller, Nadir's asteroid was still massive, half a kilometer wide, moving at 72,000 kilometers per hour. Its collision unleashed energy far beyond anything humanity has ever witnessed. Geographic spread. With Chicxulub in the Americas and Nadir in Africa, the impacts were on opposite sides of the ocean. If simultaneous, no corner of Earth could escape their combined effects. Some scientists even speculate that both asteroids were part of a binary system, traveling together through space until gravity tore them apart, sending each on a path toward Earth. If true, then the extinction was not just a tragic accident, but a cosmic ambush. The case for one villain, yet not everyone is convinced. Many paleontologists argue that Chicxulub alone explains the extinction. It was, after all, far larger, 200 kilometers across, dwarfing Nadir's 9. Its impact hurled trillions of tons of rock into the sky, ignited global wildfires, boiled oceans, and shrouded the planet in darkness for years. Compared to this apocalypse, Nadir might have been little more than a grim footnote. And there are questions about dating. The margin of error in geological clocks leaves uncertainty. What if Nadir formed 1,000,000 years earlier or later? In that case, it played no role in the dinosaurs' downfall, serving instead as a reminder that Earth has always been a target in the firing line of space. The human question. The double impact theory also forces us to ask a haunting question. What if it happened again? Asteroids like Nadir are not unique. In fact, impacts of that size are expected once every 50,000 to 100,000 years. Humanity has simply been lucky. Chicxulub-sized events are far rarer, but not impossible. If one were to hit the Atlantic today, the results would be catastrophic. Entire coastlines, New York, Lagos, Rio de Janeiro, London, would vanish beneath tsunamis. Firestorms would engulf nations. Dust clouds would choke crops, plunging billions into famine. Civilization itself might collapse. For dinosaurs, there was no defense. For us, the question is not if we can prevent such a disaster, but if we will be ready when the time comes. So, was it one asteroid or two? The truth may never be known. The ocean keeps its secrets, and 66 million years is a long time for evidence to fade. But whether Chicxulub stood alone or was joined by Nadir, the result was the same. The age of dinosaurs ended. Not with a slow decline, not with evolution phasing them out, but with the brutal efficiency of cosmic violence. In the blink of an eye, their world was torn away. And yet, their story is not truly over. Birds, their living descendants, still take to the skies. In every sparrow, eagle, and hummingbird, a fragment of the Cretaceous survives. Life, though fragile, endures. The craters remind us of two truths. 1. Extinction is swift and merciless. 2. Survival is stubborn, persistent, and often surprising. So when we look up at the stars, we are not just gazing at beauty. We are looking at the same heavens that once delivered death to the mightiest creatures Earth has ever known, and perhaps, one day, will test us, too.